What if I told you that the future of AI is here and it's transforming the way we interact with technology? What if I told you that you could be a part of this revolution? Welcome to the world of large language model operations, or LLMOps. Attention AI pioneers. I'm Blaze, and today we're diving deep into the world of LLMOps. If you've ever wondered how AI tools like GPT-4 work behind the scenes, or if you're curious about how these powerful tools are deployed in real-world situations, then you're in the right place. We'll be exploring everything from choosing the right base model, prompt management, testing, deployment, and monitoring. We'll also be looking at some exciting case studies, discussing the challenges in LLM ops, and revealing the tools and resources you need to get started. So buckle up, because we're about to embark on an AI adventure that you won't want to miss. Hello, and welcome to our deep dive on large language model operations, or LLM ops. My name is Blaze, and I'm with Lang Labs. Today, we're going to explore the fascinating world of LLM ops and how it's revolutionizing the way we use and interact with AI. So sit back, relax, and enjoy. Large language model operations is an emerging field that focuses on managing the entire life cycle of large language models, from data management and model development to deployment and ethics. It provides a standardized end-to-end workflow for training, tuning, deploying, and monitoring LLMs, both open source and proprietary. This accelerates the deployment of generative AI models and applications. LLM ops is essentially a new set of tools and best practices to manage the life cycle of LLM-powered applications, including development, deployment, and maintenance. Companies like Hugging Face, Human Loop, NVIDIA, and Lang Labs are paving the way in this space. At Lang Labs specifically, not only are we the premier AI and automation agency, we also offer top-tier LLM ops services for your AI LLM application needs. So let's define LLM ops. We define LLM ops as the management of the entire life cycle of large language models and LLM applications through the application of MLOps principles, so machine learning operations principles. It's focused on increasing efficiency, scalability, and reliability in the development and deployment of LLMs and applications. LLM ops has become a crucial aspect of AI development. Developers can ensure that their models are developed and deployed more efficiently with fewer errors and greater reliability. Choosing the right large language model for your application involves several trade-offs. These include factors such as the quality of the model's output, the speed at which it can generate responses, the cost of using the model, its tunability, and data security considerations. GPT-4 is often a good starting point for many applications. It is a proprietary model developed by OpenAI and offers high-quality outputs. However, it may not be the best choice for all use cases due to its cost and potential limitations in fine-tuning. When choosing an LLM, it is important to consider the specific needs of your application. For example, if speed is a critical factor, you might choose a model that is smaller and faster, even if it sacrifices some quality. If data security is a concern, you might choose a model that allows on-premises deployment. Proprietary large language models are developed and maintained by specific companies or organizations. They offer high quality outputs and have been trained on extensive and diverse datasets. However, they may come with usage restrictions and costs. One of the most well-known proprietary LLMs is GPT-4, developed by OpenAI. It has a seemingly uncanny ability to mimic human language and is often used as a benchmark for other LLMs. Another example is Bloomberg GPT, developed by Bloomberg. This is the first LLM built specifically for the finance industry, demonstrating how LLMs can be tailored to specific domains. Databricks has also developed DALL-E 2.0, a large language model that customers can own, operate, and customize. While proprietary LLMs often offer high-quality outputs, they may not be the best choice for all use cases due to their cost and potential limitations in fine-tuning. Open source large language models are freely available for use and modification by the public. They provide a cost-effective alternative to proprietary models and can be a good choice for organizations with specific needs or constraints. Here are some of the notable open source LLMs. We have Bloom, the world's largest open multilingual language model developed by Hugging Face. H2O GPT, an LLM developed by H2O AI that excels in performance and is fully open source and commercially usable. There's Stable LM, a suite of open source LLMs released by Stability AI, the company behind the AI-powered Stable Diffusion Image Generator. Now we have T5, Flan T5, Pythia, DALL-E, Stable LM, Llama, Alpaca, Vicuña, Koala, and Opt. Try saying that all at one time, 5 times in a row, super fast. These are some other open source LLMs that have been developed and fine-tuned by various organizations and researchers. When choosing an open source LLM, it's important to consider the licensing terms. Some models may have restrictions on commercial use or other conditions. Prompt engineering is a critical aspect of working with large language models. It involves crafting the input prompts to guide the model's responses in a desired direction. Prompt engineering is often an iterative process involving exploration, perturbation, testing, and iteration. Visual analytics tools like PromptAid can help in this process. Prompt tuning is another technique used to guide LLMs to perform specific tasks. It involves learning soft prompts, which are trained weights that can be fed to a frozen language model along with the input to obtain the required results. There is a growing need for tools that support the creation of corpora of prompts. Prompt Source is an integrated development environment and repository for natural language prompts. These techniques and tools make prompt engineering more like engineering and less like ad hoc experimentation, leading to more reliable and predictable results. Testing large language models presents unique challenges. Here are a few key reasons why it's hard. Unknown training data. LLMs are typically trained on vast amounts of data from the internet, and the exact data they were trained on is often not known. This makes it difficult to predict their behavior in all situations. Difference between production and training distribution. The data distribution in the real-world use case production may be different from the data distribution the model was trained on. This can lead to unexpected model behavior. Complexity of metrics. Evaluating the performance of LLMs is not straightforward. Traditional metrics like accuracy of F1 score may not be applicable or sufficient. The quality of the model's output can be subjective and context dependent. Size of the model. The sheer size of LLMs makes them hard to test. They have billions of parameters and can generate a vast number of possible outputs. Lack of ground truth. In many cases, there is no single correct answer, making it difficult to evaluate the model's output. Despite the challenges, there are effective strategies for testing large language models. Incremental evaluation sets. Building evaluation sets incrementally can help capture a wide range of scenarios. These sets can be expanded over time as new edge cases are discovered. Focusing on hard examples. LLMs often perform well on easy examples, but struggle with more complex or nuanced ones. Focusing on these hard examples can provide a more accurate picture of the model's capabilities. Using the LLM to generate test cases. LLMs can be used to generate diverse test cases, which can then be used to evaluate the model's performance. Zero-shot classification tasks. LLMs can now be evaluated on zero-shot classification tasks with evaluation on the hub. Big Bench, a collaborative benchmark designed for measuring and extrapolating the capabilities of language models. Remember, testing is an iterative process. The goal is to continually improve the model's performance and reliability. Evaluating the performance of large language models is a complex task. The choice of evaluation metrics often depends on the specific tasks and the availability of a correct or reference answer. Here are some commonly used metrics. Accuracy measures the proportion of correct predictions made by the model. Calibration assesses whether the model's confidence in its predictions matches the actual correctness of those predictions. Robustness evaluates the model's ability to maintain performance when faced with adversarial or out of distribution inputs. Fairness and bias measures the model's fairness and the presence of any bias in its predictions. Toxicity assesses the presence of harmful or inappropriate content in the model's outputs. Efficiency evaluates the computational and time efficiency of the model. Zero-shot evaluation, a popular way to measure the performance of LLMs, as they have been shown to learn capabilities during training without explicitly being shown labeled examples. Remember, no single metric can fully capture the performance of an LLM. A combination of metrics is often used to get a comprehensive understanding of the model's capabilities. Deploying and monitoring large language models in production environments is a complex task. Here are some key considerations. Deployment. Deploying LLMs involves setting up the infrastructure to run the model, integrating the model with your application, and ensuring the model runs efficiently. Monitoring. Once deployed, it's crucial to monitor the model's performance and behavior. This includes tracking the model's accuracy, latency, and resource usage, as well as monitoring for any unexpected or inappropriate outputs. Improving output quality. Techniques like reinforcement learning from human feedback, RLHF, can be used to improve the quality of the model's outputs. Safety and misuse. It's important to consider the potential for misuse of LLMs and to implement the safeguards to prevent harmful or inappropriate use. Best practices. Organizations like OpenAI, Cohere, and AI21 Labs have developed the best practices for deploying and monitoring LLMs, as well as LangLabs. Remember, deploying and monitoring LLMs is an ongoing process that requires continuous attention and adjustment. Test-driven development, TDD, is a software development approach where tests are written before the code. This approach can also be applied to the development of applications with large language models. Here are the main components of the process. Write a test. Define the expected behavior of the LLM in a specific scenario. 2 is run the test. Run the test against the LLM. Initially, the test will fail because the LLM has not been trained or fine-tuned to meet the test expectations. Next, update the LLM. Modify the LLM or its prompts to make the test pass. This could involve fine-tuning the model, changing the prompt, or adjusting the post-processing of the model's output. Then, lastly, repeat. Repeat this process gradually, building up a suite of tests that can define the desired behavior of the LLM. This approach creates a virtuous cycle of improvement, where each test helps to improve the LLM's behavior, and the improved LLM, in turn, enables the creation of more sophisticated tests. The field of large language model operations is rapidly evolving. Here are some trends to watch out for in the future. Multimodal learning. Future models won't be restricted to learning just from text. They will be trained on data from other modalities. For example, images, audio recordings, and videos. To enable more diverse capabilities, provide a stronger learning signal, and increase learning speed. Widespread deployment. Over half of data scientists and engineers say they plan to deploy large language model applications into production in the next 12 months or as soon as possible. Next generation LLMs. The next generation of LLMs will continue to push the boundaries of what's possible with artificial intelligence. Efficiency and accessibility. As LLMs continue to grow in size, there's a push towards making them more efficient and accessible. This includes efforts to shrink LLMs without sacrificing performance, improved human likeness. Future LLMs might focus on learning fewer words to sound more human and improve their conversational abilities. Remember, the future of LLMOps is still being written. As practitioners in the field, we have the opportunity to shape its direction. And at Lang Labs, we promise that we will always be at the forefront of the latest trends and research for LLMOps. So that is our promise to you. In a case study titled Large Language Models in the Workplace, a case study on prompt engineering for job type classification, the authors discuss the application of large language models in the context of job type classification. They highlight the importance of prompt engineering in achieving high performance and discuss various strategies for effective prompt design. For one of the companies that Lang Labs has developed an LLM application solution for, not only did we develop the backend solution for their startup company, this is for under NDA, but it's in the CRM niche. Not only did we develop the backend solution for this, we had to go through the prompt engineering and fine-tuning process to ensure an accurate response for their specific use case. So we have demonstrated experience in prompt engineering as part of the LLMOps sphere. A survey conducted by Forbes reveals a massive shift towards the adoption of large language models in the industry. Despite the challenges, over half of data scientists and engineers plan to deploy LLM applications into production in the next 12 months or as soon as possible. The survey also highlights the rise of prompt engineering and dominance of OpenAI's models in the field. We totally understand the complicated technical aspect of this industry. At Lang Labs, we are committed to assisting business owners and aspiring entrepreneurs in their journey to adopt AI and LLM applications into their existing systems and processes or into future applications that they want to develop. Implementing large language models in production systems is not without its challenges. Here are some of the common issues faced. Resource intensity. Building larger language models requires significant computational resources, which are often beyond the reach of all but the most well-resourced AI labs. Model size versus innovation pace. The pace of innovation in the GPU chips used to run AI is lagging behind model size, meaning that we could soon face a brick wall beyond which scaling cannot plausibly go. Efficiency. Efforts to push back against the logic of scaling are underway. Techniques like training smaller models on far more data using a mixture of experts and exploiting a property known as sparsity are being explored to boost model efficiency. Accessibility and risks. Broad accessibility to LLMs also carries risks. While it's great to see more people engaging with LLMs, it's important to remember that these are still very much research models not suitable for widespread use. Hardware limitations. Current hardware is not well suited to exploit sparsity, a promising future direction for compressing models. Further hardware innovation is probably needed. Techniques for smaller models. Many of the techniques that are effective at compressing smaller AI models don't appear to translate well to LLMs. Scaling laws. The fight against AI scaling laws also faces more prosaic challenges. It's often easier to throw computing power at a well-understood model architecture than fine-tune new techniques. There are several tools and resources available for implementing large language model operations. Here are some of them. Of course, you have yours truly here at Lang Labs. We have our partners at Honeyhive, where you can build, evaluate, and continuously improve your LLM apps in production with human feedback, quantitative rigor, and safety best practices. There's Databricks. Databricks provides a platform to integrate pre-trained large language models into your workflows and offers capabilities to fine-tune LLMs using your own data. There's the Hugging Face Transformers library. This open source library provides pre-trained models that can be easily integrated into your workflow. There's Deep Speed, an open source tool that can be used for fine-tuning LLMs with your own data for better accuracy. DALL-E 2.0, a large language model trained by Databricks that demonstrates how you can inexpensively and quickly train your own LLM. There's Managed ML Flow. They provide built-in and production-ready MLOps for model tracking, management, and deployment. There's the OpenAI models. OpenAI provides a range of models that can be integrated into your workflows on Databricks. GPT-4 tools, a tool proposed to efficiently enable large language models to use multimodal tools. Implementing large language model operation requires careful planning and execution. Here are some of the best practices that we recommend at LangLabs. Prohibit misuse. Publish usage guidelines and terms of use of LLMs that prohibit material harm to individuals, community, and society. Build systems and infrastructure to enforce these guidelines. Mitigate unintentional harm. Proactively mitigate harmful model behavior. This includes comprehensive model evaluation, minimizing potential sources of bias in training corpora, and techniques to minimize unsafe behavior. Thoughtfully collaborate with stakeholders. Build teams with diverse backgrounds and solicit broad input. Publicly disclose lessons learned regarding LLM safety and misuse to enable widespread adoption and help with cross-industry iteration on best practices. Treat all labor in the language model supply chain with respect. Providers have high standards for the working conditions of those reviewing model outputs in-house and hold vendors to well-specified standards. Document well-known weaknesses and vulnerabilities, such as bias or ability to produce insecure code, as in some cases, no degree of preventative action can completely eliminate the potential for unintended harm. In conclusion, large language model operations is a rapidly evolving field that is crucial for the successful deployment of large language models in production systems. It involves various aspects such as choosing the right base model, prompt management, testing, deployment, monitoring, and following best practices. While there are challenges in implementing LLMOps, there are also numerous tools and resources available to aid in this process. As we continue to advance in this field, it's important to keep in mind the ethical considerations and strive to mitigate any potential risks associated with these powerful models. We at LangLabs are committed to advancing the field of LLMOps. And if any of this stuff interests you or if you have any questions, make sure to connect with us. Make sure you like, comment, and subscribe. One of the best free ways to connect with us, the LangLabs team, is through our free Discord. That will be linked below. If you have a specific business need or are interested in a consultation, be sure to check out our website, langlabs.io, and connect with us. We offer fully done for you LLMOps as a service, as well as general consultation / coaching to help you implement these LLMOps tools and techniques into your workflows. All of the references used to build this presentation will be linked in the description below. LangLabs is committed to staying at the forefront of LLMOps and maintaining our premier expert status in this field. We are going to be #1 in LLMOps, and we will continue to be. Thank you for joining us, and I hope you enjoyed.